Let's start with the intersection of sets. So if I have two sets, I'm going to draw a picture here for this. This is called a Venn diagram. Okay? These are my two sets. The first circle represents my set A. I'll label it A. And the second set represents my set B, which I'll label B. The intersection, can somebody tell me what part I should shade for the intersection here?
The part in the middle.
The part in the middle is called the intersection. And the notation for intersection of A and B is A intersect B. It's an upside down U. Alright? That means A intersect B. So if I say, for example, the set A is all the students in Ms. What's her name again?
Graves.
Ms. Graves' English class. And set B is all the students in Ms. Will's math class. Then what's in the intersection of that?
Everybody that's in both classes.
Everybody that's in both classes. Does that make sense?
Well, I'm not in English.
So not everybody, but yeah. Everybody good? So let me give you an example. The set, I'm going to use roster notation, which means I'm just going to list what's in the set. The set 1, 2, 3, 4, 5.
So label it roster?
Yeah. Notice there's no such as. I'm not describing. I'm actually listing everybody in it. That's called roster.
Oh.
Intersect the set -2, -1, 0,
Without repeating.
1, 2, 3. Right. So I've listed two sets. Everybody in two sets. Okay. What's the intersection?
1, 2, and 3.
Right? 1, 2, 3. It's what's in both. Is everybody okay with that? All right. Now, how does that relate to inequalities? If I say right interval graph and right interval notation for the conjunction -2 less than x and x less than 1. When we use the word and, it's called a conjunction. I'm not sure. I think they even use the word conjunction in grammar too, right? Yeah. The word and, it's a conjunction. Okay. So now, what am I looking for? I'm looking for all the x's that satisfy both of those, right? At the same time. That makes sense?
Yep.
It's like an intersection, isn't it? If it's in both sets.
So it's -1 and 0.
Okay, so we're going to start by actually drawing first. What does -2 less than x look like? The first one.
-1, 0.
Let's put -2 on this and let's put 1 on this, okay? On the number line. So now, for -2 less than x, which way do I shade? Be so careful.
Right.
So -2 is smaller than x. If I had written this normally, wouldn't you have x in front?
Yeah.
Doesn't this mean the same thing as what? X is what?
Greater than.
Greater than -2. So which way would you shade?
Right.
To the right. Right? And then I'm not going to shade it though yet. And then what about less than 1? Shade to the left. Are those endpoints included?
Yep.
What? Who? What?
No.
No, there's no equals there. It's less than, right? So it's not included. So I'm gonna use circles this time, if you don't mind. It'll just be easier because I don't know where the interval is right now. Neither of those endpoints is included. Now which interval got shaded twice? The one on the left, the one in the middle, or the one on the right? Well, what's to the right of -2 and to the left of 1?
0.
Actually, this whole interval, right? I know it includes 0, but it's not just 0, right? But it's also negative 1.99999. So it's everything in the middle. So the middle interval. The middle interval, is that okay? Everything in the middle is bigger than negative 2 and smaller than 1. Everybody agree?
Yeah.
So that's what the and refers to, is that piece that's shaded. Okay? All right. So the word and I could have written,
So how do we write the answer?
so now it says, let me read it again, graph and write interval notation. So I've graphed it, right?
Yep.
How do I write interval notation here? What's the left endpoint?
Comma 1.
Good. Left point, comma right endpoint. And then what do I put?
They're not included.
Not included, so I use parentheses on both of them.
Yeah.
Are they only included when it's very
Yes, if there's the equal sign. If it's or equal to, then it's included. Yes, that's correct. So, I want you to notice something here. The way it's written, the original problem, negative 2 less than x and x less than 1, there was a more efficient way of writing this, more concise way of writing this. And that is this. Negative 2 less than x less than 1. Isn't that what I wound up shading?
No.
Look at the graph, you'll see that. The guy's bigger than negative 2 and less than 1. When you write it together as a compound inequality, that's what this is. This is a compound inequality.
That's only talking about the middle part, right?
It is. Yeah, when you write it with those 2 arrows, we're talking about this middle part, yeah. And the compound inequality has the word and in it. Listen to it again when I read that. Negative 2 less than x less than 1. It's the same as saying negative 2 less than x and x less than 1.
So how do you write it when it says or?
So you can't use this if it says or. You can only use this if it says and it's talking about something in the middle like this, okay? So, and that's also why they wrote it with the x on the right here. You see that? And with the x on the left here? All right. So that the arrows would both be pointed to the left. You see how both arrows are pointed to the left? All right, and yeah, so you can combine them into one inequality. So let's look at, I'll get to the or in a few minutes. Let's look at solving and graphing negative 1 less than or equal to 2x plus 5 less than 13. Solve and graph. Sorry. How do I solve?
So
You
break it up
subtract
first,
5?
Subtract 5 first, sure.
Because you gotta work, you gotta do one side first,
No,
right?
would you break it
And
up?
another?
You're trying to get x alone. You don't have to break it up. I know the book that does, whatever.
Yeah, well, it does it sometimes. Sometimes it subtracts it all at once, and sometimes it tells you to do
Yeah, I would not break this
side
up.
and then the other.
So where are we picking 5 with? So
Trying to get x alone in the middle. Who's bothering x? 2 and 5, right? Who do you get rid of first? 5. It's being added to what do you do? Where do you subtract it from?
All three sides.
All 3 sides. What do you get?
Negative 6 is equal or greater
Less than or equal to x.
less than 7.
Is it 7?
8.
8. And then these divide by 2.
Yes, divide by 2. Being so careful. Did you divide by a negative?
No.
Okay, then you can just wipe your brow and forget about being careful. So what do you get? Okay. Is that okay?
Yeah.
All right, so now we've solved it, and it says solve, and I guess, let's see, I think they want it in set builder notation.
What's that?
How do we write set builder notation?
x such that negative
Set of x such that homina, negative 3 less than or equal to x.
less than
Negative 4.
or
Okay, so that's set builder notation.
So all you had to do was actually just put a
Yeah, frame it.
X and then put the little.
Exactly. Frame it. Right? I like to call it frame it. Okay, so now, graph it. How would I graph it?
Oh my goodness. A graph with -3.
Do they just want a
a
number
graph
line?
with 4.
Yeah.
Oh, I can do that.
Okay, -3 and 4. Where do I shade?
3 is included. It's less than.
Where do I shade?
In between 3 and 4.
Right? X is in the middle, monkey in the middle.
Dot at 3.
Shade in the middle.
Dot.
A dot on 3, -3,
Circle on 4.
and a circle on 4. If you want, you could have used square bracket on -3 and parentheses on 4. That's okay also. Now, interval notation, anyone?
It's gonna be bracket. -3, comma, 4, parentheses.
You guys are awesome. Or I'm awesome. I can't figure out which.
Oh, you know that.
Yes. What's the question?
Also listeners. You know how you did the -2 less than x less than 1?
Uh-huh.
You know how they're all those both are going to the
Left.
left, right? So there's a problem on the homework where you have two numbers like that. They're both negative, and it goes. I think I had like -2 and -5. And you have to write it down, but you only use one. And then infinity, it's negative.
I know.
Infinity.
I know which one you're
I
talking
don't know
about.
which one I have to use.
Okay. But when you use a compound inequality like this, I want you to notice the arrows have to be pointed in the same direction. The other thing is if you cover up the x in the middle, it has to make sense. -3 is smaller than 4. That's correct, right? Okay. And I'll get to what you're asking. Yes.
Is that standard form where it says in the set builder, you switched it around, right? And then you color it in. So you switched that -3 less than greater than. Is that?
I didn't switch it because, what did I switch? What are you talking about switching?
Like in the other example.
I didn't divide by a negative, so I didn't flip the inequality. Example. Solve and graph 2x minus 5 greater than or equal to -3. And, the word and, 5x plus 2 greater than or equal to 17. All right.
Still intersection?
Yeah, the word and does mean intersection, actually.
So it's still intersection?
Yeah. Because it means both, right? Satisfies both. Okay. So now, let's try solving each of them separately first, okay? If that's okay. So how do I solve the left one?
You always have to get x alone.
Get x alone.
Add 5.
5 to both sides.
Add 5. I get 2x greater than or equal to 2. And then? Divide by 2. Good. And you get x is what? Greater than or equal to 1. And let's look at the second inequality. How do I solve it?
Subtract 2.
Subtract 2 from both sides. You get 5x greater than or equal to 15.
X is
Dividing by 5s. X is greater than or equal to 3.
oh, snap.
And there's an and. Oh, snap. Do you guys mind if I graph? Okay. I'm going to do, actually, in this case, I'm going to do 3 graphs. I'm going to do a graph for this guy. I'm going to do a graph for this guy. And then I'm going to do a graph that's the answer in the middle, if that's okay. All right? So graph x greater than or equal to 1. What do? I write 1. Shade to the right. And 1 is included to put a dot. For x greater than or equal to 3, it looks the same way, doesn't it? except now I've got 3. Okay. Notice that my left, that I'll put 3 on my left graph as well, and 1 on my right graph as well, if that's okay. Now, what part got shaded twice?
Oh,
3
1 and 3.
3 to infinity.
Oh. What? No.
Yeah.
It's those
Yeah. 3 to
Do you guys agree? 3. So 1 to 3 only get shaded on the left graph. So this really, look here. Watch this. 1, 3. There's, if you write 1 and 3 on your graph, that it breaks it up into 3 pieces, doesn't it? The left part never got shaded, right? That's definitely not my answer. The middle interval got shaded for the left graph, but not the right graph. Only got shaded once, that's right. And the right interval is the one that got shaded both times, right? So what's the answer? Shade the right interval. And do I include 3? Yeah, because 3 got shaded both in both graphs. Was included in both graphs, wasn't it?
Yeah.
So the final answer is
No.
in interval notation. What would interval notation look like?
3 comma infinity parentheses.
3 comma infinity. Is 3 included?
Yep.
So I put a, is infinity included?
No.
The better answer is never. Never. So parentheses for that guy. So there's my interval notation. Isn't this fun?
No. Yeah, but you know, is the homework going to be like this?
Yes. Exactly like it.
Exactly?
Definitely ain't fun.
Exactly.
Wait, what's that bottom little circle thing?
Say again?
Infinity.
Infinity, yeah.
Oh, wait. Oh, you're talking about the side where it's 8.
The later
Yeah.
8.
Oh, not the little bracket.
So what do you guys think? Should I get an infinity ring for my like a tattoo? Tattooed on my finger?
Hey, my brother has that.
Don't put it where your wedding ring would be. Everybody I know that tattoos their wedding
tramp
finger.
stamp.
When they're married, they end up divorced. Every single person.
Okay, we'll do that.
Get on your lower back.
No, but get it something else.
What? Say that again?
No,
don't do it. I just got a big
Tramp stamp.
Okay.
lower back. It was painful. Don't do it.
So let's look at this one.
Get it on your foot.
2x minus 3. Somewhere inconspicuous, like the bottom of my foot, greater than 1.
Put it on your ankle.
But if you get it on your foot,
And-
it's off quicker.
Bottom of it.
Because it's more
3x minus 1,
Bottom of it.
less than 2. Okay, you guys ready?
No.
Can you each solve both of those?
No. Yes.
Go ahead and solve on your own papers.
Ooh,
Really?
that's cold.
Wait,
Can't see the problem.
I can't
That's not what she's talking about.
So now, I'm going to go ahead and do 3 graphs again, if that's okay. I'll do a graph for this left guy, a graph for this right guy. The left guy looks like 2. Shade to the,
Right.
but don't include it. For the second graph, shade to the, but don't include it. So far, so good? Okay, now, the answer is because of the word what? What are we looking at? And, since there's only one word in the whole problem, the word and, we're looking for what got shaded twice, right? What should I put on my number line?
Nothing.
What numbers? 1 and 2. Okay. The left end point, did it get shaded?
Yep.
How many times?
All the way to infinity.
Only one time. And my right graph has it. The left interval is only shaded once.
Yeah.
The right interval is only shaded once. So that's the other graph, right? The part in the middle, did it get shaded? No. So what got shaded twice?
Nothing.
So what's the answer?
Is it no solution?
No solution.
Yay.
Oh, okay. That makes sense.
So there's only a solution if it gets shaded twice.
Yeah. It has to be shaded in both graphs.
Is that what you're saying?
So how do I write? That's called the empty set. If I want to do set builder notation, you can write a set in roster notation if you want. and it just is a set with nothing in it.
Oh, that's nice.
That's pretty cute.
Yay.
Or what we more likely do is just write what's called the empty set. And the empty set is a big O with a line through it. It means the set with nothing in it.
That comes up on the homework, but with numbers on the other side. Like, I think it was, I don't know, a whole bunch of, it's like maybe 2x minus 3 is greater than, and that symbol.
No. Then that's a 0 in that case. Because that's talking about a number 0, and then this is talking about set. It's a big wide circle. It's not an oval. Mine looks like an oval. It should be a circle. A circle with a line through it. I just didn't want to make it look skinny like a 0.
I'm not sure which one it was, but it is in the homework.
No.
Okay.
In like the,
Okay. So that was all intersection and conjunction, right? Intersection and conjunctions. Right? Conjunction meaning the word and.
Yeah.
Okay. I want to show you something kind of funny. The intersection symbol, if you draw a line through it, looks like an A for and.
Or it's an
Okay.
wow, there's love. You write that down.
All right. Moving on. We're going to look at unions and disjunctions. Unions, I love that. And disjunctions. Yeah, what was that from? The song? Conjunction Junction? Schoolhouse Rock, that's right. The union of two sets. If I draw the set A and the set B, like that, the union refers to everything in both. Everything in either one. Does that make sense? Everything in either A or B. Did you hear me say the word or? Everything that's in A or B.
Not and.
Not and, but or.
A or B.
Right. And we write it A union B. U for union. Okay. Go unions.
Almost German, that's it.
Okay, so let's look at this example. The set 1, 2, 3, 4, 5 union. The set -2, -1, 0, 1, and 2. What's the union?
Everything, 1, 2, 2.
Yeah.
Okay, start with what?
-2.
-2, -1, 0, 1, 2, 3, 4, 5. Does it have everybody in it?
Yeah.
It should. That's what union means. Okay? So, in algebra, all I had to say was the word algebra. And I got an uh-oh. If I say x less than -3 or x greater than 3, this is called a disjunction. And it means all of the above, right? It means everybody who's either less than -3 or bigger than 3. Let's draw a picture of that. I'll put -3 and 3 on a graph. Who's less than -3? Which way do I shade? Left. Not included. And where do I shade for x greater than 3? To the right. Not included. That whole thing is the solution to x less than -3 or x greater than 3. Because it means that either x is smaller than -3 or x is bigger than 3. It's not no solution. It's everybody here and there is part of the solution. How do we write that? Good point. Well, we could do it a few different ways. We could do it in set builder notation. We can graph it, which I've already done. What would set builder look like? The set of x such that x less than -3 or x greater than 3. Literally copy it. Copy and paste. Is that okay?
So sometimes with the homework, you try to figure out.
Interval notation? You want to try interval notation? What would interval notation look like? Look at the graph. What you'll notice is that there's actually two intervals being. There's two intervals.
It's that sign. Yeah, like a squiggly.
So it's like negative.
Where?
It's like negative infinity, comma -3. That's for an interval.
X is less than -3 squiggly.
Or.
Oh, that says or.
Oh, that says or. Sorry.
Really? We're gonna work on that. You're not a doctor.
So is set builder notation like negative infinity, comma -3?
Set builder is what I just wrote.
Oh, I'm sorry. Interval notation.
Interval. There's actually two intervals.
So it's like negative infinity, comma -3.
That's the first interval. And do I include the endpoints?
No.
No, so what do I write?
Parentheses.
Parentheses. And then to show the or, you use the union symbol.
Oh, man.
And now write the second interval. What's my left endpoint there?
Parentheses, 3, comma, infinity.
Positive infinity.
And is infinity included?
Parentheses.
What's the answer to that? Never. That's interval notation. Because it's two disjoint sets, you have to write both of them, and you write the U in the middle to show that both of them are. Okay? All right.
It gives the example.
So now solve.
Oh.
Solve 7 plus 2x less than -1 or 13 minus 5x
Is that a negative one?
less than or equal to 3. Yes. Less than or equal to 3. All right. So
Uh-oh.
I do, but it's in my thing. You need it right away? Okay. So what do I do?
Subtract 7.
Right, solve each one. So why don't you guys go ahead and solve each one? Okay, don't forget that you have to flip the symbol when you divide by -5 on both sides so you get x greater than or equal to 2. So now, to graph this guy, remember you don't have to have 3 different graphs here to graph it. You could just do it right away because you're going to graph everybody anyways, right? Because of the word. Or you're going to include everybody, so just do it once, right?
Yep.
So what numbers do you put on the graph?
-4 and 2.
-4, 2. For x less than -4, shade to the left. And what about -4?
Way to the right.
Not included. For x greater than or equal to 2, shade to the right. And what about 2? It is included, so put a dot. Since the word or is there, we're just graphing both of them on the same graph.
Yep.
Now, set builder anybody?
Set x such that negative is it would be x is less than -4 or x is greater than or equal to 2.
Good. Use the word or. And then for interval notation, notice I have how many intervals? Look at my graph. 2 things are shaded. 2 pieces are shaded, right? So you need an interval notation for each one. What's the first one going to be?
Negative infinity, negative 4.
Neither of which is included, right? Negative infinity or negative 4. And then do I use the union or the intersection symbol? Union. U for union. And then what's the right interval? Bracket. 2, comma, infinity, parentheses. 2 is included, so it's got a square bracket. We're going to solve 3x minus 11 less than 4, or 4x plus 9 greater than or equal to 1. Solving each one separately, you guys let me know what you get. I'll pause and you guys can pause too. Graphing now. What do I put on my graph?
Negative 2 and 5.
Good, you guys said negative 2 first, so I'll put that on the left. Just because you said it first. Actually, because negative 2 is smaller, right? Okay, so the first one, x less than 5. Which way do I go? And is negative 5 included? Or is 5 included? Sorry? No. How about x greater than or equal to? That's right.
No solution.
Which way do I shade? For x greater than or equal to negative 2? To the right? And is that included? Yeah. Who got shaded at least once?
Anything between negative 2 and 5.
Negative
Oh.
2 and
At least once.
After
Oh, my
5.
bad.
Everything.
Who said that? Everything.
Oh, everything.
See, I was right though.
You include everybody that got shaded at any point in this.
Because
So guess what the answer is?
infinity to infinity.
It's the whole graph.
Infinity and infinity.
The whole graph is the graph of it.
Is it bracket?
Okay, so can we do set builder?
Set builders such that infinity.
Set of what? X such that?
X is less than 5, comma, no. Infinity
How do you say?
equal to negative 2.
No, look at the final graph. Has nothing to do with negative 2 and 5.
So you just put x such that infinity. You still
Even better.
what? You just leave it? A 0 thing?
Real number.
All the numbers. Oh, you cheated.
All real numbers, right? How do you do that? As looking at the graph. Use the graph to help you write interval notation. What would interval notation for that look like?
Negative infinity, comma, infinity.
Right.
Good.
It's not so bad.
It's not a bracket?
That's a bracket. No. It's
No,
never
because
included.
infinity and negative infinity are never, ever, ever included. Never. Infinity and negative infinity can never, ever, ever be included.
Never, ever. 8.
No, no, no.